All right, so this is the most exciting class we've ever had here. So you guys ready? So let's hear it. So class.
Yes.
Thank you. I gotta wait a second next time. Dang it. Okay. All right, so maximizing area. So if you guys already started the homework, you saw there's like two questions already like this, right? There's one with a rectangle, another one with a triangle, right?
Yeah.
Okay, so we're going to do this it's inscribed, so that means it's on the inside of the circle. Radius of the circle is 2, and we know a lot about a circle. So what I'm going to do is I'm going to take the equation of the circle. So the equation of the circle, the origin is at 0, 0. So that's going to be x squared plus y squared equals r squared. Since the origin is at 0, 0, the center of the circle is not moving anywhere, right? Because the original formula is x minus h closed squared plus y minus k closed squared equals r squared. So that's the original, if you forgot what that is, okay? So, and where h and k are where the coordinates of the center of the circle, and r is the radius of the circle. So we're just going to use this one right here, and so if we do have another equation that you need to move it because you'd like to.
Move it.
Thank you. All right. Yeah, just so you will have it in your notes also. So this is at 0, 0, so I get x squared plus y squared equals r squared. In this case, my r is going to be 2. The radius is going to be 2. So if the radius is 2, I get x squared plus y squared equals 2 squared is 4. And we're trying to maximize the area, right? The area of the rectangle. So area of the rectangle. So let's write the equation for the area of the rectangle. So what's the area of the rectangle going to be? Kind of, but we have some variables here we got to use.
Oh, 2x, 2y?
2x
Times
1y.
Oh,
Because it's only going up, right? Length is
Oh.
2x. My height is just 1y. That's where we get that. Okay? So we have 2x times y. Now, whenever we're doing this, we're actually using two equations to solve for one of the others. So since I have two variables in my area formula, I have an x and I have a y, I'm going to use the equation of the circle that I have over there to be able to go through and isolate. So let's get rid of my y, and that's going to be the easiest thing to do because why not? So if I isolate in my equation to get y by itself, I'm going to have y equals the square root of 4 minus x squared. You guys agree?
Yes.
Yeah, so just did a little bit of algebra. So I moved the x squared to the other side and square root of both sides. And why is it not a plus or minus?
Because it can't get negative space.
I could. This is the equation of the circle. Am I using the lower half of the circle?
No.
I'm not using the lower half. That's the reason why I'm only going to use the upper half of the circle.
Because the rectangle is inscribed in
Yeah, it's inscribed in the upper half. If it was inscribed in the lower half, it would have a negative out front.
there. Okay.
Okay? But, yeah. Anyway, what else do I have? Okay, so I got that. So I'm going to replace that with y. So now I'm going to have my area is equal to 2x times my 4 minus x squared to the 1/2. Because that radical, it's easier to write it as a 1/2 instead.
It looks like y sub 2.
Yeah. okay. Oh, now I see it. Now I see it.
Yeah.
Okay. All right. So now to be able to do my derivative here, this is a what rule? It is a chain. This one's a chain, and this one's a product. So I have a product and a chain together. So I'm going to go to the next page so I could actually have enough room to put everything on there. There you go. So this is my F and this is my G. So that's my product, and my product's got a chain. So F prime would be 2, very good. And then G prime, actually let's just go G in the first place because it is going to be a chain. So let's U. So what would I U?
4 minus x squared.
Yeah, so I would say U four minus x squared, and then U prime is going to be
8.
not 8,
Negative 2x.
negative 2x, right? Okay, so I have my U prime, and so let's go off to the side over here. So I got my U prime, so now this is going to turn into my G is now U to the 1/2. That's my G, right?
Yes.
Okay, so take the derivative. So the derivative is 1/2 U negative 1/2 times
U prime.
U prime, which is negative 2x, and then put it back.
Yeah. Put back U.
Okay, put back the U. So I'm going to take care of that negative also, so I'm going to move it to the bottom. So on top, I'm going to have a negative 2x over a 2 to the, let me see, that's going to be 4 minus x squared to the 1/2 in the bottom.
Oh, I thought you could just multiply negative 2x with the 1/2.
Yes, I did. So
Oh.
yeah, the 2's going to be up top, and I will cancel it. I
Oh,
just
you-
wanted to show my work.
You just put it in a different form.
Yeah, I'm just showing my work before I cancel. So yes, now I could actually cancel my 2's, make life a little bit easier. And that is going to be my G prime. So yeah, my product had a chain in it, so now I have everything written out, and now I can put my product rule together. So my product rule is F prime G, so that's going to be 2 times G, which is going to be my 4 minus x squared to the 1/2 plus G prime F. And in this case, I'm gonna put the F first because my G prime is really ugly. So why not? So 2x times negative x over 4 minus x squared 1/2, like that. Are we okay so far? Yes, no, maybe?
I see
Hopefully.
it. Yeah.
Okay, so we put it all together, and now let's go ahead. I'm going to do some algebra with this. So I'm going to clean it up a little bit before I actually combine like terms. Okay, to combine like terms, I have to have common denominators. So my common denominator is eventually gonna be the quantity of 4 minus x squared to the 1/2. And this one right here currently is just over 1, right? If that's over 1, and that's my denominator, I need to multiply top and bottom by my common denominator. But when I end up having, I have 4 minus x squared to the 1/2 times 4 minus x squared to the 1/2, that's gonna give me a whole, right? 1/2 plus 1/2 is 1 whole, and that's gonna clean up a lot that I have on the top. But before I do that, like I said, I wanna clean this up a little bit. So it's gonna be 2, 4 minus x squared to the 1/2 over 1, and this is gonna be minus 2x squared over 4 minus x squared to the 1/2. Okay, common denominator. There's a lot of red here. I need to change that. My common denominator, quantity of 4 minus x squared so when I do that, that's going to make these two quantities become one whole because it's 2 over 2. And then I'm going to be left with 2 quantity 4 minus x squared to the 1, so I'm just going to leave it like that, minus 2x squared over 4 minus x squared to the 1/2. Give you a second to catch up. Morning. Are we alright? Haven't finished your coffee yet? Do we need more coffee? Maybe some crack? Let's make a little crack in the coffee. Gotta get that extra boost. Alright, so I'm gonna do my distribution now. So as I do my distribution, I'm gonna have 8 minus 2x squared minus 2x squared over my denominator of 4 minus x squared 1/2. And remember, all this is still equal to my area, my derivative of the area in terms of x. Now this next part is going to make life super easy. What's the goal of actually doing all of this? If I'm optimizing, that means I'm either getting a minimum or a maximum. And what do I know about the minimum or maximum? What do I know about their derivative?
What?
The minimum or maximum. Okay. What do I know about the minimum or maximum? Remember, the derivative is always the, what's the derivative?
The slope.
It's a slope, right?
Yeah.
And so at the maximum or the minimum, the slope has to be
Negative or positive?
0.
Oh, okay.
Remember, the slope is 0 because it's increasing it, slope is
Stops.
0, and then changes direction. So my derivative of either the minimum or the maximum is always going to be 0. So I'm doing all this right here, all this math, just to the point where to say, hey, I want to set this equal to 0. And when I do that, that's going to clean up a lot more of my math. Okay? So, but before I get too far, I'm just going to clean up the top, and I'm going to put on another page here. So, cleaning up the top because I have like terms to combine. 8 minus 4x squared over quantity 4 minus x squared 1/2. Okay, one more page over. I have my dA dx, and this was 8 minus 4x squared. Okay, now, my whole point was trying to get to this point right here where I set this equal to 0. So I go 0 is equal to my 8 minus 4x squared now I can clear out that bottom, right? Danny, how would I clear out the bottom? Yeah, multiply by the denominator, but when you multiply anything times 0, you get. So that means that I can clear out that whole bottom and not even have to worry about it, because anything times 0 is 0, so that's going to leave me the top. The top is 0 equals and 8 minus 4x squared. Can I factor anything? Yeah, I can factor out a 4. So if I factor out a 4, I'm going to be left with 2 minus x squared. And by factoring that out, that's going to clean up that 4 also, right? Because I could divide both sides by 4, and then it's going to take care of that 4. That 4 is going to be gone. And now I'm going to be left with 0 equals 2 minus x squared. Move the x to the other side, which makes it positive. X squared is equal to 2. So therefore, I get x equals plus or minus square root of 2. And there's a reason why I have the plus and minus here. Because it's a possibility of both, right? And if we're dealing with coordinates on a circle, a plus and minus is possible, right? Because that means that my x could be a negative rad 2, so I'm going to the left rad 2, or I'm going to the right rad 2. That's what that means. So back to my values. That means that right here, this is going to be a, going in this direction, negative rad 2. This one over here is going to be a positive rad 2. But when I'm talking about the area, can I use the negative? Say no.
No.
I can't use the negative because I can't have negative area. Can't have negative area, only could have negative people. Right?
Okay.
Okay. So, when we're dealing with the area here, so now I could plug that back in because I know what my x is. I could solve for y. And I'm going to plug it into the other equation, which is this right here. Because if I plug it in over there, it's not going to help me out. It's just going to tell me what my area is going to be. So right here, as I plug this in, I'm going to get my y value, which goes this way. So I get y equals the square root of 4 minus rad 2 squared. What's the problem with that?
Too many square roots. Well,
Too many square roots? Okay, so inside, what is the square root of 2 squared?
it's just 2.
Just 2. 4 minus 2? 2, right? 4 minus 2 is 2, and then I have the square root of 2. There we go. That one's not a plus or minus.
Oh, Oh, yeah, it's.
because it's already set up in a radical over here, and I'm only doing the equation of the top, right?
Yeah.
So that's why this one is not gonna be a plus or minus. So as I plugged in here, I did the math and I came up with just square root of 2. Okay? So from there, let's figure out what my area is gonna be. So my area now could go back to this one right there. So the area is gonna be 2 times radical 2 times radical 2. So there's my x and my y. So rad 2 times rad 2 is rad 4. What's rad 4? 2. Yeah. It's going to be just 2 times the 2 out front. So 2 times 2 is 4. So the maximum area is 4 units squared. Now, we went a little bit above what this question was even asking for. So, it said find the dimensions of the rectangle. Alright, we found that. We found the x's and the y's. Right? We found all the dimensions right here. So, the x value is going to be 2 rad 2. From there to there. Because I can't add a negative. Because if I add the negative rad 2 and the positive rad 2 together, what do we get? 0. That definitely is not 0, right?
Negative distance, let's go, 0 distance.
Yeah. Anyway, so that's why I just combined the two, the distance from there, and I combine those as 2 rad 2. And then the y distance is just going to be a rad 2. So I have the dimensions of my rectangle, and that over there, which wasn't really required, but we went through and actually did it anyway, because on some of your problems you're going to have to do it. So we found out what the maximum area was. Yes.
How did you get 2 rad 2? Because I don't understand how adding radicals work. Okay, so that's,
Because you have a rad 2 going in each direction, right?
yeah.
So yeah, just because this is going to the left doesn't mean it's still not traveling a rad 2, right?
Yeah, it's still traveling.
So it's traveling rad 2 that way, and it's traveling rad 2 that way. So together, we get 2 rad 2. Because I have 2 of them with the same variable. Now, that's the same reason why. So if you treat the radical as if it is a variable, x and x, how'd you get that it was 2x, right? Just treat the radical as if it's a variable. So radical 2 is your variable, and if you got 2 of them, gives you 2 rad 2. If it was rad 3s, I would have 2 rad 3s.
Okay.
A little bit better?
Yeah.
Okay. Alright, so good question though. Alright, so, that being said, right here, I'm just going to go over this. This one has it's kind of like a theorem to go along with it. So if you do need it on any of this stuff, it is there. So there is an equation, which there is a long, lengthy process to actually get to this point. But I'm just giving you the formula if needed. Light travels at different speeds in different media. So air, water, glass, etc. Suppose that light travels from point A in one medium where its speed is c1, which is constant 1, to point B in another medium where speed is constant 2. Fermat's principle, that light always travels along the path that requires least time to provide Snell's law of refraction. So we have 2 different things. So using this right here, it's a law of sine basically for this. So we're just using my theta here and my C is the light, how fast that it goes, that it's gonna travel. And then over here, with my other angle down here, it's also gonna be the same thing, but it's also gonna be proportional to whatever medium or whatever it's going through. It's kinda like if you ever look at a fish in water, okay? Yeah, so light is refracted, so it's slightly different. So if you're looking at a fish, it's not really exactly where it's at. You would have to actually adjust for that because the way you see the light going in is different than where they actually are.
Wow, okay.
So if, let's say for instance, you were, in an apocalyptic wasteland, not really, because you wouldn't have fish anyway. But yes, so you had to go live in the wilderness for a while. So, and you need to go hunt a fish. You're like, all right, I got this spear. I'm gonna go kill me a fish. There's some fish in the water. So when you're looking at it, if you throw it directly at the fish, you're not gonna hit.
Okay.
Because the way light refracts, okay, if you were to go directly at the fish, you would miss it. It would go over the fish. And so what you have to do is you have to try to actually go below the fish because the way that light refracts, that you're not actually seeing where it currently is.
Okay.
Does that make a little bit more sense?
Yeah, because water magnifies, like, when you put it across
Yeah,
the water.
it will magnify, and so yes, and it does travel differently through water. That's why.
That formula looks like the law of sine, except we missed
It is the law of sine.
Oh, okay.
Yeah.
You're just missing a side.
It could have been one more, but we don't actually have a third for the law of sine, but it's the same thing as law of sine.
Yeah.
Alright, so that being said, I'm going to give you guys the rest of this time. You guys are all going to like, share, and subscribe. And then, okay, again, there was only 12 questions. So hopefully you guys could actually do those questions now with the inscribed circle and, was it inscribed triangle?
It was an inscribed triangle.